Problem solving is about finding solutions to problems which do not have an immediate fix. Generally, the problem solver does not have the necessary resources or knowledge to find the answer directly. This pushes the solver to use critical thinking and creativity to consider different strategies with the knowledge and resources they do have to find a solution. Problem solving has no single approach. The students choose a strategy around how they think to find a solution. It is important to explain problems open-endedly with no obvious preference of problem-solving strategy. It is also important that students understand that there are numerous approaches to finding a solution. Teaching through problem solving provides students with a more engaging maths with real context, situation, and exploration. Teaching through problem solving provides a student with further skills, engaging students' critical and creative thinking, and building students' sense making. Teaching about problem solving provides students with a clear understanding of how to problem solve through steps and strategies. Polar's problem solving steps are an example of this. It provides students with a structured approach to finding a solution to their problem. First, understanding the problem, then selecting a strategy, attempting this strategy, and checking the solution. Guess and check gets students to use their critical thinking and sense making to make an estimated guess to the solution of a problem using Pollar's problem solving steps, then reevaluate and progress closer to the answer using trial and error. This is a Year 4 problem. By the end of Year 3, students would show mastery of measurement and be familiar with the geometric shapes and their attributes, linking to the content descriptor of measurement and measuring shapes. There is also a partial link to algebra with the use of simple algebraic equations. So here is the problem. A farmer is planning to plant a rectangular garden in her backyard. She has 220 meters of planks. She can choose the dimensions of the garden, but it must be a rectangle. What dimensions can the garden be? A rectangle is a four-sided polygon, also known as a quadrilateral. The opposite sides are parallel to each other, and all the angles are 90 degrees. A square is a special kind of rectangle as it holds all the attributes of a rectangle. Additionally, all the sides are equal. It's important to point out that all squares can be rectangles, but not all rectangles can be squares. Based on the knowledge that we have, we know that the width, which I'm going to represent as W, is equal to the length, which I will represent as L. So using the perimeter, P, which is, as we know, 220 meters, we can divide it by 4, which is the number of sides, which gives us 55. So we now know that all the sides are 55 meters. So that gives us the largest possible width. We know that a rectangle has two parallel opposite sides. So these are the width and these are the length. So we know that the perimeter, which I'll represent as P, is equal to the length plus the width plus the length plus the width. So we can make that an easier term. You know that P, the perimeter, is equal to 2 lengths plus 2 widths. So we have the knowledge that altogether the perimeter is 220 meters. So we now have the perimeter, we divide it by 2, which will equal length plus width. So we know that the length plus width has to be half of the total of the perimeter. So that means we have 110 equals length plus width. In order to find the solution to the problem, we have to assume either length or width. I choose width. So to change the problem so that we can find the length, we have to rearrange the equation. So length equals 110 minus width. So I choose the width to be 1. 1, which gives us 109. If I redid this problem and changed the width again, the length equals 110 minus 2. That gives us 108. So if we were to put this in a table, width and length. So we know when the width was 1, the length was 109. We also know that when the width was 2, the length was 108. So we can see a pattern here. When the width increases by 1, the length decreases by 1. In order to speed this up, I know that the maximum width is 55. So the length is also 55. This shows us that there are 55 different solutions to the problem.